Welcome to the Example Selector tutorial. In our previous video, Unlocking the Power of Few-Shot Learning with OpenAI LLM, we thoroughly discussed what few-shot learning is, how to use a few examples when crafting prompts, and how this influences the LLM's responses for new products or queries. We also covered the benefits of few-shot learning and asked the question, what would you do if you had many examples? Would you use all of them, just the first or last few, or pick some at random? If you're unsure, don't worry. In this video, we'll explore this topic in detail. If you missed our previous video, you can find the link in the description. I highly recommend watching it before you continue with this one. Now let's get into the example selector. The example selector is a component used to select relevant examples from a data set based on the current input or query to include in prompts for the language model. This can improve the performance of the model by providing it with contextually relevant information based on the input it receives. Now let's look at the different types of example selectors. First, length-based. Second, NGramOverlap. Third, Similarity. Finally, Maximal marginal relevance. It's time to dive deep into each type of example selector and understand how they work. Let's talk about the length-based example selector. This selector is used to choose examples based on their length. The main goal is to ensure that the entire prompt, including the selected examples, fits within a specified token limit. This is particularly useful when working with models that have strict token constraints, such as those found in many language models. Why is this important? Language models often have a maximum token limit, which is the number of words or characters they can process at one time. If your prompt exceeds this limit, the model might truncate the input, leading to incomplete processing and potentially less accurate or meaningful responses. By selecting examples that fit within the token limit, you can ensure that the model receives a complete prompt, allowing it to perform at its best. Here's how length-based example selector works. First, specify the maximum length of the prompt according to the LLM model you are using. Second, calculate the length of each example. Then, examples are chosen in such a way that the total length of the selected examples does not exceed the specified maximum length. By doing this, we make sure that our prompts remain within the token limit, allowing the model to process them efficiently. Now let's explore the NGramOverlap example selector. This selector chooses examples based on the overlap of n-grams between the query and the examples. An n-gram is a contiguous sequence of n items, which can be words, characters, or other units from a given text or speech sample. The goal of the n-gram overlap example selector is to find examples with the highest n-gram similarity to the input query. This means selecting examples that share the most sequences of words or characters with the query. Doing so ensures that the examples chosen are highly relevant to the query as they contain similar phrases or terms. Here's how n-gram works. First, split the query and examples into n-grams, a process called tokenization. For instance, let's take an example and a user query and split them into bigrams. Consider the sentence, "Machine learning is a defining feature of the modern world." This is our existing example, and the bigrams of this sentence are machine learning, learning is, and so on. Now, machine learning is fun is the user query. Here are the bigrams of this user query. Calculate the overlap of n-grams between the query and each example. This involves comparing the n-grams in the query with those in each example to see how many match. The number of overlapping bigrams is 2. The total number of bigrams in the first sentence is 9. Here is the formula to calculate NGramOverlap, and the calculated overlap value is 0.22. Select the examples with the highest NGramOverlap. The higher the overlap, the more similar the example is to the query. This is particularly useful in tasks where exact phrase matching is crucial, such as information retrieval. Now let's learn about the Similarity Example Selector. The Similarity Example Selector is a method for choosing examples that are most similar to a given query or input based on a similarity metric. This process helps identify the most relevant examples that closely match the context or content of the input. By selecting examples that are highly similar to the query, this method enhances the accuracy and relevance of the generated responses or outputs. Here's how similarity-based example selector works. First, convert the input query and examples into vector representations. This means transforming the text into numerical forms that a computer can understand and process. Common techniques for vectorization include using word embeddings like word2vec, glove, or more advanced methods like BERT. Second, compute the similarity between the input query vector and each example vector. This is typically done using similarity metrics, such as cosine similarity, which measures the cosine of the angle between two vectors, or Euclidean distance, which measures the straight line distance between 2 points in a vector space. Finally, select the examples with the highest similarity scores, the examples that are most similar to the query based on the chosen metric are selected for use. By using the Similarity Example Selector, we ensure that the examples chosen are contextually and semantically similar to the input query. This means that the model can generate responses that are more precise and relevant to the input query. Now let's explore the Maximal Marginal Relevance Example Selector. MMR is a method that balances relevance and diversity by iteratively selecting examples that are both relevant to the query and diverse from each other. This approach is particularly useful in contexts where you want to ensure a variety of examples in your selection. By choosing examples that are not only relevant to the query but also different from one another, MMR helps generate responses that are more informative and varied. Here's how MMR works. First objective is to select examples that are most relevant to the query. This means finding examples that closely match the content or context of the input query. Second objective is to ensure the selected examples are as diverse as possible. This involves avoiding examples that convey the same information, thereby providing a broader range of perspectives. The MMR algorithm operates by balancing these two objectives. It iteratively selects examples by considering both their relevance to the query and their similarity to already selected examples. By doing this, MMR ensures that each new example added to the selection is both relevant to the query and distinct from the examples already chosen. Now let's summarize and discuss the differences between various example selectors. Length-based selector focuses on ensuring that the total length of the selected examples stays within a specified token limit. However, it might compromise on relevance and diversity since the primary criterion is the length of examples. NGramOverlap selector captures specific word patterns and phrases by looking at the overlap of ngrams between the query and the examples. However, it might not capture the overall semantic similarity, focusing more on exact word matches. Similarity-based selector focuses on finding examples that are most relevant to the query or input based on a similarity metric. However, it may lack diversity since it prioritizes examples that are very similar to each other. Maximal Marginal Relevance Selector balances relevance and diversity by iteratively choosing examples that are both relevant to the query and different from each other. By doing so, MMR helps generate responses that are more informative and varied. With this, we have reached the end of this video. So far, we have learned what an example selector is, the different types of example selectors, and their differences. Understanding these differences allows you to choose the right example selector for your specific needs, whether it's meeting token limits, capturing specific word patterns, ensuring relevance, or balancing relevance and diversity. Thanks for watching. Please like our video and subscribe to our channel and stay tuned for new updates.